In this tutorial, we'll be covering the steps that are required to make a network patch cable. There are two wiring standards, the 568A and the 568B. The most commonly used standard is the 568B. However, it should be noted that all government contracts for network wiring require the use of the 568A. Both ends of the cable should have the same standard used when pinning out and crimping on the connector. This will ensure that data will flow from one end of the cable without the wires crossing. Testing the cable is not necessary, but can reduce the amount of headache that you have later on when you're using the cable. When you're learning how to create a network patch cable, it is best to take it slow at start and get familiar with the steps and the process. This will ensure that mistakes are kept to a minimum and the job is done correctly. Here we have a picture of the tools that will be necessary to create our network patch cable. Number one is the cable itself. Shown here is a category 5E cable. The process will also work on a normal Cat 5 cable. The Cat 6 cable has a little bit different process when you are attaching the connectors, so that would be a different tutorial. Number two is the crimpers. We use this tool to crimp the connectors onto the wires once we have them placed in the connector properly. Number three is the connectors themselves. The common name is an RJ45, which is actually a misnomer. The proper name is the 8P8C. Number four is a sheath cutter. This is a handy little tool that is used to remove the blue sheath from the cable. Number five is a cable tester. This tool comes in handy once the process is complete to make sure that the wires are oriented properly in each end of the cable itself. The first step in the process is to remove the sheath. As pictured on the left, place the cutter 3/4 of an inch to an inch from the end of the cable. One or two spins around the cable will be enough to scar the sheath for removal. Next, you will flex the cable, as shown on the right, at the scar mark to remove the sheath. The next step in our process will be to separate the wires. There are 4 pairs of wires inside the cable itself. We will untwist and separate each one of the single strand of wire. The center insulator that you can see in the middle picture needs to be trimmed back so that the connector can slide all the way down to the sheath. The bottom picture on the left shows all of the wires that are separated and fanned out so that you can have them in the proper order later on the next process step. One thing to watch out for during this step is to inspect each one of the wires. On the bottom right hand corner of the slide, you can see a cable wire that has a bare spot. This bare spot will allow crosstalk once the connector has been placed over the wires. This is something that will slow down the speed of the data transmission and something that you should really avoid. This diagram shows the proper arrangement of wires in the 568B standard. The proper order from the top to bottom is orange-white, orange, green-white, blue, blue-white, green, brown-white, and brown. Notice the orientation of the clips and the pins on opposite ends of the wires themselves. It is important to make sure that when attaching the connectors that this is followed so that the data flows straight through the cable. In order to have a proper seat of the connector on the cable itself, it is important to trim back the wires once we have them in the proper order. On the left hand side, you can see using the connector to measure the distance that the wires should be sticking out from the sheath. On the right hand side, most of your cutters or crimper tools have a cutter made into the handle. You can use a marker or your fingers to mark where the cut should be made and use a crimping tool to cut off the excess wires. Make sure that the wires are kept in the proper order during this step. Once we have the wires trimmed to the proper length, we will be inserting them into the connector. On the left hand side, you can see that the connector is slid over the wires with one hand while the other hand holds the wires in the proper order. Once the connector is slid in, you will notice that there are channels that each wire should be sliding through in the connector itself. Push the connector all the way back until the ends of the wires are seen at the end of the connector. The sheath should also be inside the connector. Once the crimp is made, the wires and the sheath will be compressed, making a firm connection. Insert the connector into the crimping tool. The clip on top of the connector will slide into a groove in the crimp itself. My suggestion is to crimp the connector 2 or 3 times to make sure that there is a good seat of the pins in the connector into the wires and that the sheath is properly crimped down. This will provide a sturdy connection that will prevent the clip from being pulled off of the cable. As stated earlier in the tutorial, testing is not a necessary step, but a highly suggested step that should be taken to ensure that the cable wires are in the proper order. The tester will send a signal along each one of the wires in order from 1 through 8 and register to see that it follows through the cable and is returned back to the tester unit. Not testing the cable after it is created could mean that the cable is improperly crimped, or there are bare spots, or the wires are in improper order. Trying to use a network patch cable with wires that are in such condition could result in the cable not functioning properly.